Even though water takes up 2/3 of the Earth's surface, it is becoming a scarce resource. Hi, I'm Leanne Williams, and today we are investigating ways of conserving and purifying our water resources.
I'm the head of disaster management at the Eden District Municipality. I'm responsible for the coordination of declared disasters as well as normal preparedness, mitigation, response, recovery in the context of disaster management. In the Eden District we have got a disaster management centre that was established according to the Act, and we've got a call taking centre, and then also the fire section also reports to me. Yes, we were in the unfortunate situation of having two declared disasters in the last 4 years. First we had the floods in 2006-07. I think a lot of the people that watched the news would recall the caimans that were slipping, and we had to close down a part of the N2. And after the floods in 2006-07, we were now faced in 2009 with a drought. So on the one hand we had abundance of water, now we've got too little water. The rainfall figures that we experienced in 2009 was the least in the last 132 years. Part of the mitigation planning in our area was to look at alternative water sources other than rainwater, so that we could tap into seawater. We've got an abundance, a big ocean next to us, but it's expensive technology, and it's specifically looking at that. Also the reuse of our current water sources. To reuse our wastewater to such an extent that we can stretch the water that we've got available. If you ask the normal person in the street, what is your water usage per month, they do not know. They do not check their water readings, they do not check their water tariffs, their water bills, because it's just too cheap. I mean, and at the end of the day, we were faced with the scenario to get people to change their way of thinking about water. If you go and you read your meter every day, you will realize how much water you're actually using. I think in the region, the permanent change came with a lot of people putting up water tanks to do rainwater harvesting.
So rainwater harvesting, as we do it, is for a number of different reasons. You could either harvest that rainwater just for irrigating a lawn or a garden. You could harvest that rainwater to top up a swimming pool, which is a similar sort of scenario that we have here. There's no major pumps involved. There's a small submersible pump inside the tank, but no, you're not sort of pressurizing that water right up to municipal level pressure. But the big thing that we do with rainwater harvesting is we actually send that water back into the home. So the water lands on the roof, runs down the gutter, comes down the downpipe, and then we've got a device called a rain runner that separates out the clean water from the dirty water. Dirty water continues to run down the downpipe and into the stormwater drains as per normal, but the clean water is now sent here into this tank. And as you can see, there's no downpipe sort of coming off of the roof and straight into it. We actually use a system that takes that clean water down to the ground, inside a pipe, and underground inside the pipe, all the way along, up the side of the tank and into the tank. So that it means you can place that tank wherever you want to. You don't have to have it sort of standing in a driveway or in front of your front door. This is the grey water chamber that we use, either for, well, this one in particular is used for the garden rhapsody. So this is the one that will take your bath and shower water and send it out onto the garden completely automatically. First rule of grey water, you never store your grey water. As soon as you've used it, you need to reuse it. Otherwise it will start to grow bacteria and it will start to smell, and you get a bad odor coming out of the sprinkler. So what would happen in a typical scenario is you've got a bath, you've got a shower, you've got a hand basin, all of those sorts of things that are in your home. As they exit the home, we manifold all of those pipes together. All of those pipes would then be brought to this central point, and in fact those pipes would all feed into the chamber at this point. The water goes in here. This is the filtration unit. It's very standard, just like a swimming pool basket, nylon basket, just to catch hair and big particles that have come down the drain. From there, the water goes through that filtration and into the pump chamber at the bottom. It goes in through the pipe down there. what happens inside here then is the water level starts to rise. There is an automatic pump inside there that's got a float switch in it. So as the water level rises, the float switch rises. As the float switch sort of hits a particular degree or a particular angle, it engages the pump. And while there's still water flowing out of the bath or the shower or the washing machine, the pump is now already kicked in. So it immediately then pushes the water out through this little hole here, and along a hose pipe, and from at the end of the hose pipe is a sprinkler, usually just a standard Gardena pyramid sprinkler. And the pump will just keep pumping no matter how much water you are sending to it. As long as the float switch is in a vertical or now in a horizontal position, as the water level starts to drop again, the pump will keep running. And when it gets down to a particular angle just before the tank is completely empty, the pump will disengage, the water will stop flowing, and you're left with just a little bit of water sitting at the bottom of the tank. So you can literally pull the plug out of the bath, grab the towel, run down the passage, go and have a look out of the lounge window out onto the grass, and there your sprinkler will be going, and the water that you've just used is now being reused.
In South Africa, we have an issue at the moment where we've run out of dilution capacity in terms of the notion that you can dilute the pollution to the point where it's acceptable for release into the environment. People can't do that anymore. And we're also a water-short country, so we don't have sufficient reserves of water to meet the needs of industry and of the consumer. And we're also not looking after our water resources properly. A lot of the activities in South Africa, be they mining or be they industry or even individuals at home, are not thinking carefully about how they're using the water resources that we've got. For instance, let's take people's personal habits. We all use personal care products. We slather creams on, we use shampoos, we use soaps, we throw bath salts into the bath, and all of that water ends up in our waste treatment plants. And a lot of these compounds are extremely difficult to remove from water. Your normal water treatment process will not deal with those components. So your own bad habits are causing a water pollution problem. And these problems are all over South Africa. As you might know, at the moment, there's a report out that says about 55% of our treatment facilities are not functioning properly. And so waterborne disease is impacting on communities, and clean water is becoming difficult for many communities, on top of which there are lots of communities that don't have water supplied to them yet. So just in terms of the average person on the street, their drinking water supply is under a lot of threat at the moment.
Our company specializes in water treatment, dependent on what the water quality is. We ask the client to send in a sample, which we then analyze and determine which system would suit their water best. The options we can offer the client is ultrafiltration, RO systems. We can even put in ion exchange resins and different micron filters depending on what the water needs.
We use a spinneret where the two solutions come together. They start off still as two liquids, and as they move down the column, they start forming a solid. And the moment they hit the water, it's almost completely solid. The water is used to get out our solvent. That's why the membrane is pulled through a long path in the bath. After 360 rotations, we cut them and we place them in blue tubes, where they then go into the bigger blue pipes where they are left in water. This is the dried membranes. They are now ready to be put into a module. 1,750 of the tubes are in a small module. The dirty water comes in this side and it's forced in at just below a bar. The clean water comes out this side and the overflow this side. On average, the clean water flux of a module is between 100 and 150 liters per square meter per hour.
We are working in conjunction with different universities, trying to incorporate nanotechnology or in the casting solution or on the inside of the membrane to combat fouling on the membrane. As you use the membrane, different fouling substances build up on the inside, and we are really trying to lessen that.
I'm Marlies Botes. I did my BSc, MSc and PhD studies at the Stellenbosch University. My PhD I did in microbiology, and now I'm a postdoctoral researcher focusing on water filtration and nanotechnology.
Hi, I'm Michelle de Kwartsniet. I also did my studies at Stellenbosch University, and I've been working as a postdoctoral student for 2 years now. And on this specific project, it's the two of us and 2 more students that's working with our supervisors, water teabag filter.
When we started the research in this field, this was not a project with a title that we are looking for a filter which will filter 1 liter of water. That was not the idea. We were actually working on filters much larger and for much larger application, where you would filter thousands of liters of water for industry and so on. But the tests that we do, you do in the laboratory, of course. So we don't have filters here which are the size of this building. So we have small little filters, and these little pieces of filter paper are about the size of around tea bag. So you filter the water through, you put the nanofibers onto the material, and you check then to see whether they actually kill the bacteria, whether they remove them, and so forth. And because the mindset of shape and size is very prevalent in my train of thought, I was standing there with the students, and we were looking at the experiments, and I was very impressed with the results that they were getting. And I looked at this, and it was like serendipity, where I said, well, you know what, why don't we also see whether we can't filter smaller quantities of water? Knowing that from experience that point of use is becoming more important. To clean your water at the point where you use it is becoming more important in the world for many, many reasons. I said, well, why don't we actually make a filter smaller and see whether this won't work? The next thing was, I went here to my boardroom, took some of the tea bags that were there, cut them open, so we had tea bag material. We filled these up with our fibers. We spun these fibers onto the filter material, added activated carbon. Danny had a hair straightener here, so we took the hair straightener, we sealed these tea bags, and we started testing them. And this is where this idea was actually born. We do science in the world primarily to make a difference, whether this is on HIV/AIDS, whether this is in mathematics or in physics. The reason why science exists is to make a difference to the life of the average person walking in the street. And they need not even know what that difference is, but it is to make that difference. Here we have something that people actually understand, and that they can see that this filter will make a difference to the quality of life of millions of people around the world. And I think this is why the media and everyone is so excited about this invention.
Our guests in studio today are 2 postgraduate students in the field of water purification using nanotechnology. Hello, Njabu and Danielle, how are you?
Hi, very well, and you?
Very well, thank you. It's so lovely to have you in studio today. Njabu, can you tell us more about yourself and what you do?
My name is Nanjavulo, and I'm a postgraduate student at the University of Stellenbosch. I'm a second-year doctoral student in the Department of Polymer Science.
Wonderful. That's great. And Danielle, what do you do?
I'm a master's student, also at the Department of Microbiology at the University of Stellenbosch. I'm in my 7th year of study, and I'm finishing my master's degree and starting my PhD in January.
Wonderful. Njabu, why did you decide to go into the field of science?
Well, I've always loved science subjects, and in particular chemistry and biology. And thus for my undergrad I did both. I did chemistry and biological sciences, and it just went on and on.
Wonderful.
So, no,
and you, Danielle?
I've also been interested in science ever since I was little, and I was particularly interested in biology, and so I did an undergraduate degree in biology, and it just went from there. I went into a postgrad degree in biochemistry and then microbiology.
Okay, and why the interest in nanotechnology?
Nanotechnology is very applicable to many different research problems. We use it in water purification, it's used in air filtration, it's used in many aspects of engineering and producing many different products. So it's a very useful field.
And why do you think that research in the field of nanotechnology is so exciting?
Well, as I said, it's a very new field and not much research has been done in this field. So there's a huge scope for potential new research, and we are doing groundbreaking, brand new research, especially in the field of water purification using nanotechnology.
Yeah. And Jabu, the media tells us that water is a very scarce resource. Is it really such a big problem?
Actually, it is. And it's actually one of the main problems facing humanity. And to make an example, a third of the world's population, especially developing countries, lack access to potable and safe drinking water.
And how can the field of nanotechnology help this problem?
From where I stand, I think coming up with new environmentally friendly and cheap ways of purification, of water purification, can really come in very handy. Yeah.
Okay. Is there any exciting projects that you have worked on, in your individual fields that you can tell us about?
Jabu and I have been recently actively involved in a research project along with our senior students and our professor at the University of Stellenbosch. We have developed and patented a new product for water purification.
Wow.
It's basically a small, cheap, environmentally little water filter, environmentally friendly little water filter that can be easily distributed among people who need safe drinking water. It's easy to use. You use it once, it completely sterilizes at least 1 liter of water, and it's disposable and environmentally friendly. So
that's incredible.
It's extremely useful, and it's going into production soon. And so it will really make a difference.
Yes, absolutely. Can you tell us or basically describe to us a day in your life, what activities you're involved in, what you do that could be of interest?
Okay, I arrive at the laboratory. Most of our days consists of lab work, being practical researchers. We conduct most of our research in the lab. We do experiments, and then of course we study the literature, constantly checking new research that's coming out to measure ourselves where we lie relative to the rest of the researchers out there, and how relevant our research is.
Yeah. And you and Jabu, is it pretty much the same?
Yeah, it's pretty much the same. Right. You arrive in the morning, and you check your literature, and then you start your experiments, and at the end of the day you record your findings and go home.
And what do you find is the response to people when you tell them what you do? Are a lot of people aware of the field of nanotechnology?
Not really, but you can make it as simple as you want it to be and as complex as you want it to be, depending on your audience. Like when I go home and my mom asks me what I'm doing, I cannot go on and on about the molecules and everything. So I just tell her I'm working on water research and try to make it as understandable to her as possible. But obviously when I go to a scientific audience, I have to communicate in a way that they will understand. Yeah, but yeah.
And Danielle, when I think of a scientist, I think of a very isolated career. Is it so, or do you get to work in a team as well?
Well, it's not that isolated. A lot of our time is spent in the laboratory working on our own, doing your individual research. But a big aspect of our careers is working in a group, working together with a research group, collaborating with fellow students, and receiving supervision from senior students as well as your professors and people within the field. So your success is very much dependent on the people around you as well.
That's good, that's good. And Jabula, what are the job opportunities that are available for students who have completed a degree in this field? What's out there for them?
There's actually a lot, but most of the job opportunities are lab-based. You work in a lab, in the food industries, pharmaceutical companies, and you can do research. It's just a lot. There's a lot out there that you can do from this field. Yeah.
And are there any exciting projects that you've worked on that you can share with us?
Well, most definitely the development of we call it the tea bag filter, the little water filter. Yes, it resembles a tea bag. That's been very exciting because we've been involved with the project since its beginning. We were involved in the development of the product. We took it through the stages of having it patented, and now through the stages of having it in production. And we took it through the laboratory testing, so that has been a big learning curve for us. And yeah, we find ourselves very fortunate to be part of such a internationally recognized research project.
And for the learners that are busy watching right now, what are the subjects that they would need to take in high school in order to study a degree in microbiology?
All the science subjects, but mostly if you do biology, life sciences, and maths, that could help a lot. But basically all the science subjects, you need to have a grip on them.
Okay.
And then,
Science and maths and subjects
Physics,
like that.
chemistry.
Yeah.
Okay. And in your opinion, how can the field of nanotechnology benefit South Africa?
Well, of course, in the field of water purification, we purify polluted water, microbially polluted water. But in my PhD, we'll also be looking into purification of mine water waste. It can also be applied in the industry of electricity, in cooling water towers. Really, it's a wide field, but the biggest impact, I would think, would be in water. Water reclamation, water purification, and just upping the level of water quality in South Africa.
Wonderful. And to end off with, do you guys have any advice for our viewers who are watching right now who wish to pursue a career in microbiology?
Yes, actually, you just have to love it, because anything done from a heart of love and willingness is exciting. Just love it and go for it.
That's awesome.
Yeah.
Danielle?
I'd have to agree with Njabu. As long as you have a passion for what you're doing, you can only succeed. Make sure that you're really interested in what you're doing and what you're pursuing, and then you'll make a good success of it.
That's awesome. Thank you so much for those words of advice and everything of the best, and we hope to see you very, very soon.
Thank you.
Thanks, ladies.
Thanks.
I will definitely be more conscious when opening a tap in the future. We all need to do our part to make sure that we do not lose such a precious resource as water. Until next time, take care.